This is good.
Are you filming?
Yes.
We're good.
Alright, we're good.
Okay, let's go.
Alright, I think children are retarded because of their parents, but he's got some difference.
We're going to Big Bang.
Yeah, Big Bang Theory now.
Okay.
But I really think that I think I'm right, but go on.
I blame your grandparents.
I blame you.
No, I think it's
I
gotta
didn't
be
have sex with your grandparents.
Yes, you did. You did. Look at my mom.
Yeah, but it was only your grandfather.
It was.
Oh, alright.
Yeah, I think it's counting.
Oh.
Hi guys.
Hey, Rachel.
Our oven's broken, so I have cookie dough.
Oh.
If you want, I can cook it, or you guys can just
Do you have eggs in it?
Hi there.
Yeah, there's egg in it.
How goes it?
Throw it in the oven.
Going good. How are you?
What's that?
How are you?
Good.
Good. Dean was just going to tell us about his. Dean was just about to give us his take on the Big Bang Theory.
Oh, I want to hear this.
Yes. Hey, Dean. I got you another fan. He wants to hear.
Okay. All right.
Yeah, you got it.
Are you listening?
I'm listening.
Okay.
I'm multitasking.
There are three main pieces of evidence for the Big Bang. The first is the redshift of surrounding galaxies. Now, are you familiar with the Doppler effect?
Kind.
Well,
I know about as much as
give a
I've
quick
learned in
explanation.
school.
Have you ever heard an ambulance go by? It goes,
Yeah, it changes because of the frequency.
Yes, because if you think of it as like if you are in a boat on a pond, while you're moving forward, the waves that are being pushed in front of you are really, really tight together.
Yeah.
But the ones behind you get really, really far apart. That happens with anything that goes through a wave. So sound and light do that as well. So in a sound wave, the tighter frequency makes a higher pitch, and the wider frequency makes a lower pitch. In light, it affects the color of light. So when you have a really tight wave together, that's a short frequency, that's where you get violet light. When it's a wider frequency, you get red light. So when we take out a telescope and we look at all of these galaxies around us, they're all red-shifted. All of their light is in a wider width of frequency than what we'd expect. Science rules.
Yes.
What's up, man?
Science!
Hey, what's up?
So,
Oh, wow. Hey.
Snuck in here.
I'm going to join your circle because you're talking about science.
So what that means is we've got all of these galaxies around us, and they're all moving away from us. But more importantly, they're also moving away from each other.
Yeah.
Now, the best way to think of this is if you take a balloon that's not inflated, and you put a bunch of dots with a marker on it, and then you blow it up. All of those dots, not only do they go away from the center, but they go away from each other on the outside of the balloon as well. And that's what the universe looks like to us. Now, if you were to go back in time, you've got all of these galaxies all spread throughout, and they're all going outward. What would happen if you reverse time? They would be coming in closer and closer together, and basically into a very small area. Well, when you look at the physics of really, really dense matter in a really, really tightened area, you're going to go to the weak atomic force and strong atomic force, and that's going to create a massive amount of energy. Well, I'm going to skip to the next point, and that is cosmic microwave background radiation. In the 1940s, a bunch of physicists said if the Big Bang Theory was correct, that there should be this really, really, really cold radiation permeating throughout the entire universe. It would be a remnant of the inflation period. And it would be around 2 degrees Kelvin, which is extremely cold. But it would be there. If like the universe just suddenly poofed into existence, you wouldn't expect it to be there because there would be no reason for it to be there. It'd basically be what it is it's like this radiation permeating throughout the entire universe that has just a very, very tiny bit of heat, but it's still heat nonetheless.
Negative 271.15 Celsius.
Wow.
Well, minus 2 degrees.
Yeah.
Absolute zero.
Yeah. And when they finally built a machine to go out into space and measure it, it was indeed there. So, and it permeates throughout the entire universe. I'm sorry. And
It's basically energy, like kind of the raw energy of the universe.
right. And I couldn't tell you the
electromagnetic energy.
I couldn't tell you the mathematical model that they use to predict this. It's big.
But it's big.
But yeah,
It's been.
but that is what they predicted, and then like 10 years later, lo and behold, it's
Everybody gonna play spin the bottle?
Yes.
It's in Village.
We're waiting for the bottle.
Yes. Invisible College with Professor Dane.
Yeah, we're learning about the universe.
Oh, I was just gonna.
And where's Alex? We need to teach your song about the universe.
Frankly, he's gonna start shredding. I've had a sufficient amount of alcohol to shred.
Well,
You're gonna have to listen to
That's the second
space
one.
first.
stand
The
right
third
there and
one
shred.
is the amount of primordial elements throughout the universe.
I was waiting for that word.
The universe,
I
if
could
you
create an
take
epic background music.
if you take every single element in the entire universe and you add them all up together and then you plot them on a graph, what you get is hydrogen, helium, everything else.
Okay.
There is more hydrogen and helium, like 100,000
That's like
times more
stars
than anything else. Exactly. These are the most basic elements. Hydrogen is just one proton, one electron, helium, two.
What's that?
It's a cooking line.
And the reason why so much hydrogen and helium is a big deal is because, again, if we expected the universe to just sort of poof into existence, you would expect there to be basically an even amount, or however whoever decided created it wanted it to be. The reason it fits with the Big Bang Theory is because if the Big Bang Theory is correct, that means that matter didn't exist yet and then had to come into existence. And the easiest way for it to do that would be to be hydrogen, because it's the easiest element to create. Now, when you take a star, it's basically just this massive ball of hydrogen, helium, a couple other gases. What's going on there is there's so much hydrogen. Well, as gravity works, you take any two objects with mass, and they want to pull together.
Yeah.
That includes even things like gas.
I know how stars work.
I think all of us are nerdy enough to understand
Well, I've actually taken
physics of these stars.
I wasn't going to run my I've taken another one that semester. That's why I'm interested.
That's how best friends we are.
Well, those are the three big ones.
I'm so much of a
And so,
shake your ass.
if it wasn't, like if God were to have created the universe, he would have had to gone to great lengths to make it look like it started in a tiny little singularity and then very rapidly expanded. So, which maybe he did.
Well, I mean,
Yeah, I-